If IVERS would like to get ready to go, we would like that. And I will go ahead and get the timer ready to start. So as soon as your presentation is up, you'll have 3 minutes to go through your presentation.
All right, thank you.
You're welcome.
You guys see?
It's coming up. Yeah, you can see it.
All right. I'll let my teammate Chun to start.
Okay.
Good morning and good afternoon and even good evening, everyone. Today, together with my teammates, Shaun and Alfred, are here to tackle the ever-growing problem of global warming caused by vehicle emissions. As we all know, about 90% of the world's population still uses fuel-powered vehicles, which hugely contributes to global warming. This has brought about unprecedented effects on our delicate environment. Although there are options of EVs, many countries in the world do not have the infrastructure to sustain them. So, in order to solve this issue, we have come up with an invention that could be installed directly to your current vehicles. I shall leave
Yes, thank you. We have designed IVERS, the Intelligent Vehicle Emissions Reduction System, to combat the harmful gases produced from vehicles' engines. This is done through processes such as oxidation and catalytic reductions. Here are the components of IVERS, as you see on screen. And some people may have questions, such as where the gas would go after it leaves the exhaust pipe, and it will go directly into the air. The size of this would largely depend on the exhaust pipe, but it won't have any drastic effects on the operations of the vehicle. This entire process does not require user input, but data may be stored for those who need it, for engineers, researchers, or even just curious drivers. If there are any questions pertaining to our invention, we encourage you to ask during the questioning time for a better understanding of our project. And together with IVERS, we could make a substantial impact in saving the environment. How much, you may ask? Just under 18% of global greenhouse gas emissions are produced from land vehicles alone, and we plan to slash that in half.
By January 2024, IVERS will be presented to the experts and explain to them how this project would be helpful to society. We will begin testing the project in 2 months' time. We will hopefully receive the experts' advice and approval of the project. After receiving experts' advice and approval, we will start to improve or implement IVERS until the end of the year. By 2025, we will hopefully receive the final approval from the experts. Thank you.
Thank you.
Have you finished your presentation?
Yes.
Okay, we can go ahead and start with the questions then from the judges.
Great job, guys, on the presentation and the idea. So my question to you is this supposed to be built on the car, or would you buy it after you already have a car? Like, who is the customer?
We could make it an extension, so people could buy it separately, but some cars may integrate this into their model already. So it comes with the purchase or a package even.
Okay, so it would be part, the person who would buy this from you would be the manufacturer of cars is who you're looking at? Is that what you're looking at?
Yes, that is right.
Okay, okay. Thank you. That's my question.
Thank you.
Okay, thank you. Thank you for a great presentation. It was thank you for that. I can see a lot of work has gone into that. I guess my question is that who would you, does your system involve development of new technology, or is it a combination of existing technologies to have a different outcome, like the outcome you want? Or like, is there any, does it involve is it a combination of existing technologies?
Yes, it is. There's no new technology being used. However, obviously existing technology can be improved to make the system more efficient.
Yep, understand. So who would help you to build your prototype? Let's say you've got a working model. Who would help you do that? How would you go about that?
I would say being able to talk to experts in the field. So we would go to, perhaps we would sell the idea here first. And if it goes great, then we would go to local researchers.
Yep, cool. Thank you. Thank you very much.
Okay, good idea. Good job, team. My question is more about the development of the process and the proposal for your prototype, and I would like to ask you about two things. First, you are putting a filter on the air intake for the engine, if I understood correctly, to filter out particulate matter and some other things, impurities and stuff like that. How are you going to deal on keeping enough oxygen supply so that the combustion happens efficiently? And second, I can see a urea tank. So does this mean that we're going to be replenishing urea into the I suppose that it's an or urea oxidation reaction? And why did you choose like this process?
All right. So for the urea tank, yes, you would need to refill it. I would say it would be at gas stations, preferably when you're going to go get gas. So we chose this process because we believe it would be the best for dealing with the emissions of our cars. And as to the question of how do we get enough oxygen, we planned for IVERS to be a more external part. So it will be after the combustion has taken place, where everything will get filtered through. And so the processes or the operations of the car will not be affected in any way. Thank you for your question.
I see. Thank you.
Actually, I have one more question. With the urea, I noticed on diesel engines, particularly here in Australia, I'm not sure about overseas as well, but they have what they call an AdBlue here in Australia, which I believe is a urea-based product. Is that similar? Like, is the urea that you're looking at adding to a petrol car similar to the product that they add to diesel engines?
I believe so, yes. I believe it will be similar.
Cool, thank you.
Any more questions from the judges? We have about 20 seconds left.
Yeah, a very quick one. The urea oxidation has like kind of a sluggish thermodynamics and kinetics. What kind of catalyst are you planning to use in order to promote this reaction?
We plan to go by selective catalytic reductions. And we're going to be using, I think it's a combination of catalysts. And it's going to convert like nitrogen oxide and that ammonia and oxygen into like nitrogen and water. That'll be the chemical things. Thank you.
Thank you.
Thank you very much, team. Great presentation.